Using Wi-Fi with your microcontroller project opens up a vast range of possibilities. You can connect to the internet to send and receive data to web services, and you can create a web-based interface to allow you to use a browser to control and interact with your project. So, let me show you how to set that up. Hi and welcome to Bytes and Bits. There's a wide range of microcontroller boards on the market these days which come with a built-in Wi-Fi chip, and that allows you to connect your project up to your local Wi-Fi network or even generate your own local Wi-Fi network directly from your microcontroller board. And of course, this opens up a vast range of opportunities for expanding your project work. You can use existing Wi-Fi networks to obviously connect out to the internet, which allows you to send and receive data to various web services and so on. And we can also then connect various devices to our microcontroller board over this Wi-Fi network to both gather data and control and see what's happening inside our projects. So in this tutorial, I'm going to do a quick overview to get you up and running with MicroPython and working with your Wi-Fi chips to get a working connection. And that will allow you to connect to both the internet, if you're connecting up to your home Wi-Fi network, for instance. And we'll also have a look at creating an access point where we can actually just use a standalone Wi-Fi network generated by your microcontroller board. And the one we're going to be using in this tutorial is the Raspberry Pi Pico W. And again, we're going to be working in MicroPython. But this anything we do in here will of course work equally well on any other MicroPython enabled, Wi-Fi enabled microcontroller, such as your ESP32 or some of the Arduino boards. As I said, this is almost like a quick tutorial which will get you up and running as fast as possible. If you want to have a full explanation of exactly what is happening inside the software and why we're doing certain things, then please do have a look at my full tutorial, and I'll put links to that in the description down below. So without any further ado, let's get started and use our Pi Pico W to connect to Wi-Fi. So using Wi-Fi with your MicroPython project is really a two-step process. The first is to actually connect to a working Wi-Fi network. And as you'll see in a second, we can either join an existing network like your home network, or we can actually get our MicroPython device to generate its own Wi-Fi network. But when we get to the actual software then, the main hard work is being done inside this package called network. So that contains a number of sub-objects and so on, which handle the actual hardware interface with the Wi-Fi chip. So we need to import that, of course, at the top of our code. This next bit here, we do need to set up some network credentials. So I'm really just putting my personal network's credentials inside this little object so that I can then pull them out of there without actually revealing my passwords. And that's just sort of for my own security. But all you need to do is to actually use string values anywhere inside your code here, and that of course will be fine for you. So we then get into the actual setting up of the interface itself. So we're going to create an object here, and we're going to use our network package and use this WLAN method. And with that, we will actually then tell it what type of connection we want to make. And there are basically two types of connections that we can choose. So this one I'm specifying here. So this network.sta_if is a constant defined inside this network package. And that will then define this as a station interface. And what that means is that we have got an existing Wi-Fi network. So for instance, our home network or some other network which is being produced by some other hardware, and we want to connect to that so that we can access devices on that network, or indeed if that one is of internet enabled, we can then go out onto the wider internet. The other option, which we'll see in a second, is the access point interface, and that's where we don't have an existing network and we want our Raspberry Pi Pico to generate its own network, which we can then get devices to join into. But let's go through this station interface to begin with, because that's the one which most people will be using. So we tell our system that that's the type of connection that we want to make. We then activate the hardware with this method call, and we then call the connect method, supplying it with our network's details, and that should start the connection process. So we can see down here, we jump then into a little while loop in this code. And what we're doing is we're just simply waiting for that Wi-Fi connection to be created. So our Raspberry Pi Pico is going to contact our router, it's going to negotiate a connection and get and ask for an IP address and so on. And that's really what's happening here. So we can check the status of our connection using this method, and that will return us back a set of values. And we can see those values listed out here. So again, each of these are constants defined inside that network package, but this is the actual value that they relate to. So before we start, of course, we'll be in the idle state. Once we initiate the connection, we will go into status 1, which is the connecting. And then after a while, we will either get a successful connection, which is denoted by a status of 3, or if something goes wrong, we will then get negative statuses, and depending on what those are, so passwords not working, and we didn't find that access point, or just a general failure, we will get back a status on that. And that's what this little bit of code here is doing. So it's checking to see if we've got some sort of either success or failure status coming up. Otherwise, it will just simply sleep for 1 second and then just wait for that to happen. So eventually then we will either fall out of that loop and we will either have a connection or we won't. So we're checking here first of all if we have a negative status, and of course that denotes an error. Or we will get a status of 3, which means that we do have an actual Wi-Fi connection, and we will then just simply print out some details. So once we connect, we can actually get hold of the connection parameters using this ifconfig method, and that will return us back a list of 4 values. So the first value is the IP address, which is what we're going to need to get hold of, because that will tell us what IP address our router has assigned to us, and that's what we'll be using to make contact with our Raspberry Pi Pico. And the rest of it then is just our normal sort of network parameters, where we have our subnet mask, our gateway, which is in effect our router address, and our DNS server, which in effect will be our router again. The Raspberry Pi will generally use the router for DNS information. So let's try that out on our Raspberry Pi Pico and just confirm that we actually get something happening. So I've uploaded that code to my Raspberry Pi Pico, and I've used the file name connect.py for that. All of the code that I'm using in this tutorial, I will create a GitHub repository which you can then get access to download all the code instead of having to type it in yourself. But if I then import that file into my system to get that to run, we can see there that it is now trying to negotiate a connection with my router, and it's managed to do that. And here we can see that it has now come back and telling me what has happened. So my router has assigned me the value of this IP address. So that is my IP address on my local network, and that will allow me to have other devices, as we'll see later on, to connect to my Raspberry Pi Pico. Now we do need to make sure that we know what that device, what that IP address is, and generally if you're reconnecting to the same network, the router will generally give you the same IP address each time you connect. Or of course you can configure your router to look at your MAC address and to specifically assign that IP address to you. But that is something that we do need to have, so whenever you do run your projects you will need to work out what that IP address is. But anyway, we now have our Raspberry Pi Pico connected to my home Wi-Fi network, and we're ready to then go off and actually use that. But let's first of all have a look at the other way around of achieving this Wi-Fi connection by using an access point. So this is the code then to go into access point interface, where, as I said, our Raspberry Pi Pico will generate its own local Wi-Fi network. So again, we're importing our network package. Here we will need to define our SSID. So SSID, of course, is the broadcast network name that will pop up as the name of the network whenever you try to connect to it. We do need to define a network password for this. So again, make sure you choose something sensible for that. And then we get into the actual setup. So again, we're initially telling it, we're using this WLAN method to tell it what type of interface that we want to set up. So this is the predefined constant, which will tell it to use this access point mode. We then need to configure our access point, and really there are a number of things we can do in there, but the basics are that we need to set up our SSID value and our password. So again, we're using these named parameters inside this method call. And once we've got that set up, we then simply turn on our Wi-Fi interface using this active method, and then our system will try to initiate its Wi-Fi system. So all we need to do there is to simply have a little wait just to make sure that that comes up. So we're just checking that active flag to see that it is, while it's false, that means that it is in the process of setting up the network. So once it goes true, then we come out of here and that's everything set up. So again, we can use this ifconfig method to pull out those 4 values describing how the network has been set up. So the IP address then will be the IP address of the Raspberry Pi Pico on its own internal Wi-Fi network. And that will generally be the same every time you set it up. It will assign itself its own IP address. And the rest of that, of course, then, the subnet mask, gateway, and DNS server don't really matter for this. Obviously, gateway then, if you are connecting to this, that's the Raspberry Pi Pico will act as its own, in effect, router. But you will find in a second that the DNS server, we don't actually have that because, of course, we're not connected to the real internet. And that really is the difference then in this access point. We don't rely on any external Wi-Fi network, so we can have this set up in the middle of a field in the middle of nowhere. But, of course, we don't have internet access. But let's run this just to make sure we can just verify that that all does happen. So this time the file I need to import is apconnect. And again, that will then start that code, and we should then see in this window over here, this is a view on my mobile phone, we should see our network pop up here. So let's run that. There we have it active, and hopefully that should pop up in a second on my system. And there we go. So if I want to then, of course, I can connect to that. I've already entered in my details for this, so that should then allow me to connect. So there we are. Again, it's saying that there's no internet, and my phone will probably complain about that in a second. There we go. And we can say, actually, no, we'll just use that network. So my phone is now connected to my Raspberry Pi Pico. If we want to talk to the Raspberry Pi Pico, that is the IP address on this network that we need to talk to. And at this point then, we are in exactly the same situation as we were with the station mode, where we have our Raspberry Pi Pico connected to a Wi-Fi network and it being assigned a particular IP address on that network. Everything else after this is identical for both types of connections. Of course, the only difference being in this access point mode, we do not have internet access. So let's have a look and see what we can actually do then with this system. So for the rest of the tutorial, I'm just simply going to be using my Pi Pico in the station mode, which will give us the sort of full access to the internet and everything else. But as I said, everything is the same for access point mode. So the first thing we're going to look at doing is to actually connect out to the internet and to use some web services. So for this, we need to import an extra package into our system, which is this request package, or in this instance, of course, we're using the MicroPython version of the request package. And that will allow us to handle various communications on our Wi-Fi network. So we basically go through and we set up our connection. So at this point here, we have our Wi-Fi connection set up. And this then is the code for connecting up to well, in this instance, a web API. So you will need to, of course, work out how to use the web API. So I'm using one for this timeapi.io. And that is a website that provides free timestamp information over the web. So for this particular API, we need to use what's known as an HTTP GET request. So if we visit this web address, we will get back some JSON data which represents our current time zone information. So again, we have got an API endpoint URL there. And then in our query string, we are giving it some data which we want to collect. So we're saying that we want to have the Europe-London time zone, because of course I'm based in the UK. But to do that then, we are using this uRequests package, and we're using its GET method to send an HTTP GET request. So once we send that GET request, it will send us back some information, and we're going to catch that in this response variable. Now I'm just putting a little bit of timing around that, so we'll see how fast our Raspberry Pi Pico is able to get hold of this information. But once we get that response back, we will, in effect, we will have some content for our response. So this is actually an object which is part of this uRequests package. And one of the attributes in that object is the content, and that is a byte string version of the information sent back from this GET call. Now, I've already said that this is going to come back as JSON, and that is one of the standard types or formats of data transmission over the web. So JSON is your JavaScript object notation, which is a cross-platform text-based data format, which is actually human readable as well, as we'll see in a second. But of course, we will need to convert that text string into data values. So the actual parsing of that is something we need to do. But of course, our response object has a built-in method. Because this is a standard thing we need to do, we can just simply call that method, and that will then generate a dictionary object where we have variables defined as our indexes in our dictionary, and then of course the values of those being the data values sent back to us. But let's have a look and see how that works then. So if I import the get time.py code, that will set that all running. So again, we wait for our connection, and once that pops in, we should now be connecting out to that web service. And we can see here that we're getting our response back from our web services. This is the raw data coming back from the web service. And if you're familiar with JSON, you'll be able to notice that that is what we're getting. So we have here value. So we have the name of this variable followed by its value and so on. So we can see here year, month, hour, minute, and so on. So let me just stop that for a second, just so we can see what's happening here. So again, we've got that JSON coming back. We've seen there that we use that JSON method to extract the date time value. So if we look at the date time value here, so that's where it's held in the return data, and we got that value, and we can see there that our MicroPython has correctly picked that out, and we've again got that JSON method returning us a dictionary of all of the return data. Now, one of the important things here is that I did put in some timing to show us how fast our Raspberry Pi Pico was accessing this data. So there we have 2 seconds, or well, you can see here it's between 2 and 2.5 seconds to actually complete that trip out to the API and to gather back that data. Now, the code that we've been using here, if you noticed, it's a single line of code to perform that GET request, and our code will actually sit and it will be blocked on that line until we get a value coming back from that GET request. So do bear in mind that when we're using this simple method of accessing data, your code can get held up for about 2 to 2.5 seconds, on this particular one anyway, sitting there just waiting for a response back from the server. So if you do embed these GET requests in the middle of some time critical loop, things are probably going to go wrong for you. So do bear that in mind. There are ways around that, which I'm not going to look at in this tutorial. This tutorial is really going to be the basic setup and basic usage of the Wi-Fi. But we can, of course, go to concurrent programming and asynchronous programming, which I'll cover in a further tutorial where we look more deep into a proper REST API for our Pi Pico or MicroPython, and that will also cover then sort of multiprocessing to get around these blocking codes. But for now then, we have our connection out to Wi-Fi. We can access web services over the internet, and we can see here that the JSON data returning back, we can very easily parse that out and then gather the data that we want. So the flip side of being able to send these HTTP GET requests is that we are able to then receive them. So let's have a look at how we can do that. And this is where we now are able to have one device on our network, perhaps our mobile phone or laptop, connecting to our Pi Pico and then gathering information from that or some other data. So if we look back at our code then, to do this we're going to need one extra package imported in, which is the socket package, which will actually let us open up a port on which our Pi Pico will be able to listen. And then if we come down in our code, so the actual generating the Wi-Fi connection is exactly the same as before, but then down here, if I can use my mouse to get down, we actually come down to actually open up a port on our Raspberry Pi Pico, which will listen for other devices trying to connect to it. So you can see here that we are setting up in this line here, this block of lines, a socket. So we need to tell our socket which IP address we're going to be using, and then which port. So ports are basically like doors which we can open onto the network, and then we can pipe or stream the information from that into our socket. So remember, from our ifconfig system, we were able to gather what IP address our router had allocated to us. So we're basically saying, I want to create a socket. It will be connected up to this IP address, which is our Raspberry Pi Pico, and port 80, which is the standard HTTP port number. So we're then going to create a socket. We're then going to bind the socket to that address information. So at this point, we have now created, in effect, a corridor from this port on our Raspberry Pi Pico into this socket, which will let us then receive information and send information. And we then tell our system to start listening to that port. So the number in the brackets on here, if you check the documentation, that is the number of queued messages that we are allowed to process. So basically we can be processing one message, have one queued up, but any subsequent messages before we've handled those will just get rejected. And then we're just printing out here. So we're saying, okay, let's print out which IP address we're listening on. And of course, that will be the IP address that we then need to connect to. So in our loop here, so at this point, we now have our Raspberry Pi has opened port 80 and is now listening on that port. So in this line here, we are using our socket to accept a connection. So that is a blocking method. So our Raspberry Pi Pico will sit at this line of code waiting for somebody to connect with it. And that actually does stop the Raspberry Pi Pico from doing any other operations at that time. It will sit here until somebody connects. So do bear in mind, if you're using this type of code, that will stop the other parts of your code from running. As I said, there are other ways around that, but I'll cover that in a different tutorial. So when we get this connection being made, this particular method will return us back two values. One of them will be a client connection, and one of them will tell us which IP address that client was connected to. So To get hold of the information, we simply need to just ask it to receive a block of data from our client connection. And that's what's happening here. So we're going to say, I want to read in up to 1 kilobyte of data. That's what this number here is saying. If it's less than that, we will just read whatever message has been sent. And we're going to collect that in this variable. And for now, we're just going to print that out so we can see what actually is coming over. When a client connects to you, it's good form to send back some sort of response. So we're just going to send back, it's just a very simple text message saying that we have received your message, and then we're going to close down the connection. And that really then just releases any resources which our Pi Pico has allocated to this particular event. And then it will go back and it will then try and listen for the next client connection. So let's have a look at this working and we'll see what information we've got coming through. So the file name I've used for this one is the receive get in that abbreviation. So that should fire up our station connection and then set it waiting, listening for some device to connect to it. So there we go. So we now have our Raspberry Pi Pico sitting at this IP address, and it's now listening on port 80, which, as I said, is the standard HTTP address. So if I copy that and then just put that into my browser, we can see a number of things happening. So first of all, our browser has got that message coming back from our Raspberry Pi Pico. So it's sent a GET request to this IP address. As we can see over here, we'll go through that in a second, our Raspberry Pi Pico has picked up a number of pieces of data, and then it has responded back with that message. So let's have a look at what's happening over here. So if we decode this a bit, we can see that we have a GET request coming in, and if I just highlight the actual GET request itself, so the GET request is everything down to there, and this then is a second GET request coming over. And this is what is sent across whenever one device is trying to connect with another over an HTTP connection, and this is what's actually happening every time you browse a website. So the B at the front of this just denotes that this is actually a Python byte string, which is slightly different to a normal string, but we'll deal with that a little bit later on. But if we have a look at the actual format of this request then, so this is a GET request. So the B apostrophe is just part of the way it's been printed out here. The actual data that we receive starts with that GET. And if I highlight that, we can see that the /r/n is actually a new line character. So the first line of our GET request contains three, in effect, words. So there are three sections separated by spaces. So the first is our HTTP method, which, as you can see in this one, is a GET request. There are other methods such as POST and so on, but we're not going to worry about those in this particular tutorial. The second word is the resource that we are trying to access. So we just accessed it by IP address. We didn't specify an actual page within this IP address. So we will just get back the default. So / is just your default resource. The third word then is our HTTP protocol, which for us at the moment doesn't really make any difference. The two bits that we're interested in now are our GET and especially then this resource. So let's have a look at how we can use these GET requests and the resource value to control and monitor what's happening inside our Pi Pico project. So we can create a number of these endpoints which allow us to control things within our project. So if we aim to allow people to have a web page control of an LED, we can set up 3 endpoints. So the first would be our default page, which allows people to call up and view the actual control web page with 2 buttons on there. And those 2 buttons will then activate an LED on endpoint and an LED off endpoint. And to activate those, we simply need to send GET requests to those web addresses. As we said in that description then, we're going to use a web page with some buttons on it. So we need some HTML to generate that page. And I've created a little file here which is just an HTML file. And I've uploaded that onto the Raspberry Pi Pico, so that's available to my project. So if we go through that, we're just setting up a normal page. On that page then we have two buttons, and when we click those buttons we will send a GET request. So by actually visiting a web page, that sends the GET request. So when you click the button, the browser will try and go to this web page, and that will then trigger our LED on endpoint and our LED off endpoint. I'm then going to add a little token into my HTML code, and we're going to use Python. So when it sends this block of text back, it's going to replace this token with either on or off, depending on what it's just done to the LED. So let's see the actual Python code to get this all hooked together. So in our Python code then, we're doing everything the same down to our main loop. So again, we're going to set up some control for our LED, and we're going to monitor its state with this LED state variable. So we do our normal thing where we're waiting for a client connection, we receive the data. We're now going to decode that byte string and turn it into a proper Python string, and that's what we're doing here with this decode. And mostly over the web we get UTF-8 encoding coming across, so we're just going to let it decode that byte string in that way. And then we're then going to print out this new raw request, which will actually be a better string formatted version of it. Now we saw whenever we looked at the GET request, basically the first line is split into 3 words. So we're going to split the whole request up into words. So doing the split with nothing in the brackets, just we'll split it on spaces. And we know then that the very first thing that we get, the very first word we get, is our HTTP method. And then the second string is actually the request URL, which is this endpoint that we want to pick out. So we're then looking to see which endpoint we've got. So I'm using the string find method here to look for this string within our URL. Sometimes the URL might have other data at the end of it. So if we do find that this string is in there, we can be pretty sure that then is somebody requesting that LED on endpoint. So if we do receive that, we will set our LED state. This is the value, this is the variable tracking our state, and then we'll actually turn the LED on. If we get an off value, then of course we'll do the off methods. If we do not receive either of those, then it's either going to be the default page or something else. And at that point, we're not going to do anything with the LEDs, because on every single request we get, we're going to send back a version of that simple led.html file. So in here, we're just working off whether we need to say on or off. We're then bringing the file in as a text file. And we're then doing the replacement of that token. So whatever we've worked out on or off, we're going to replace that token that we created with that new bit of text. And then we're going to send that back to the browser. And the browser will recognize that that is a web page, some HTML code coming across, and it will display it in the proper way. And again, then we're going to close our connection. So in this way, we are intercepting our GET requests. We're working out what endpoint the person has requested. We're then able to take some actions within our project to answer that request. And then we're sending back some information to let the user have some indication of what's actually gone on within our project. So let's set that up and running on our Pi Pico. So if I import the simple LED code, our system should set itself up and then wait for some connections. So again, if I browse to this web address, we should get our web page interface coming up, and you can see there we have our GET request coming through to our Raspberry Pi Pico. And on the actual circuit board, we're looking out for that little red LED. So if I turn the LED on, we should get that coming on. And we can see again in our Pico then we've got a GET request to the LED on endpoint, and that of course turned the LED on, and it's being reported back then in our web page itself. And if I turn that off, we should see it again working on there. Please don't worry about the other circuitry on that board. I'm partway through making the more advanced API version of this code. So again, all of those other bits and pieces will be involved in that. So that's pretty much it for this simple web tutorial. So we're now able to generate a web page that acts as a front-end control panel for our project. We've seen that our MicroPython can respond and intercept these GET requests and then take action. We can use buttons on our project page to control various devices, and then report back to our user through the web page by putting various bits of data into the HTML code. So that should cover everything you need to Wi-Fi enable your MicroPython projects. As I said at the beginning, this is very much a basic web interface. I will cover a more in-depth REST API version in the next tutorial. So please do make sure that you subscribe to my channel to make sure you don't miss the notifications as to when I release that next video. So I hope you've enjoyed this tutorial. I look forward to seeing you again sometime very soon. So bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.